Hi, I came across this idea, SurfacePlan. This project suggests that cars should put the engines in the wheels, and with sticks poking out of the wheels, they are going to contact the road surface to push the car forward. So it is actually like making a walking car with the additional step of putting the legs in the wheels so the wheels turn so the car moves forward. It is definitely a creative idea. That also doesn't mean it is going to be usable in the real world. So the SurfacePlan is actually made by a single person, and I'm sure he can make a working model of this, but it is a bad idea. And I want to brainstorm about why it can be a bad idea. And this was published in a couple of news articles, so that means this is an official project that we can dig into. But I want to be quick about this. I actually made a long form of this video, even longer than what this is currently. And in that one I drew lots of illustrations in my iPad. But surprisingly, I'm a very boring person when I'm drawing on my iPad. Even more boring than this, can you imagine? So let's start with what the project actually suggests. It suggests that this is going to be a more simpler way to accelerate the car forward. So instead of an internal combustion engine and all of the other parts it comes with, like the transmission, we are instead going to have these little sticks in the wheels, which we can call them linear actuators. That is the technical name, but we have to have hundreds of them. Why? Because we want continuous acceleration. So we are going to have at least 25-30 of them around the wheel, and we want to have multiple rows of them side by side, because these are going to have very small contact area to the road. So it is best for us to just have 4 or 5 rows of them so we can have maximum grip to the road. But that is already too complex for me. This means we are going to have at least 100 of them in a single wheel. And if we put them into 2 wheels, that is 200 of them. If this car is an all-wheel drive, that is 400 of them. That is 400 small moving parts. And all of them has to get energy and data, and they should send some sensory data back. We are going to talk about that later. It is already too complex, it is not a simple project. And we should also compare this to the EVs too. Electric vehicles only have a single engine or 2 engines right beside the wheels. It is actually a simpler way to do this. So I think EVs already win this video. A battery connected to 2 electric engines that are connected to 2 wheels, that is the most simple car that you can make today. You don't need any more moving parts, you just need a couple of brakes, and you can even use regenerative braking. But let's continue with the SurfacePlan. We still need the energy somehow, so we are going to still have a battery in the car. SurfacePlan suggests that this is going to make cars lighter. It is obviously going to not do that because we still have a battery in the car, and we didn't throw out the engine, we just made the engine into small parts of 200 linear actuators, so the wheels are heavier now. The car is definitely not lighter, and you have to power 200 of them individually. Like, that is too much cabling. It is going to be a disaster for maintenance and repairability. But let's say we made sure that it is a really easy and a compact design. We still have this rotating wheel that we have to somehow power through a rotating mechanism, and we need lots of current and voltage to make this work. We are still pushing a car that weighs more than a ton. There are some solutions out there for powering through a rotating mechanism, but you are going to lose some efficiency or reliability. Let's talk about physics a little bit here. You have to have lots of power in these linear actuators, like a kilowatt per actuator or more. You also have to make sure that they are reliable, they are sealed because there is dirt and water in the road. They also has to be precise, because when you grip onto the road, you cannot just do any movement you want. It has to match the car's movement, because when the car is moving forward, that point you attached yourself to is going to move backwards. So all of those actuator tips to not slip, they have to exactly track the road and the point they are attached to. So they also have to report back their exact position. And you might want to put some more sensors and cameras under the car to make it more precise, which is going to make this project even more complex. All of these are going to connect back to a single hub. There's lots of cabling, and you are going to need big mathematical algorithms. All of these are going to still generate heat because of the movement, because of internal friction and the electric motors in them and the friction in the steel part, and they have to be fast, like really fast. When you're going at 100 kilometers per hour, that is 60 miles per hour, your wheel probably rotates around 12 times per second. That is per second. We have 30 of these actuators around our wheel. That gives us around 10 milliseconds to respond to the road. These actuators have to be really fast, and they have to be really strong with high force delivery. It is an amazing project, and we don't have this technology right now. There are like 10 different types of linear actuators. You can search them up. None of them fits this project. Some of them are just too short. Some of them are not fast, not reliable, or not sealed enough. They generate heat. You cannot use them 30 times per second. So this is a complete new engineering challenge for everyone. Also, let's talk about geometry. So when you first contact the road and start pushing, you both have a horizontal vector which pushes the car forward, and you have a vertical vector that does nothing. That is just lost energy, and you cannot fix that. This is how geometry and physics work. If you push with a wider angle, of course you are going to have a bigger horizontal vector, but then your linear actuator has to be longer and longer until you can't even reach that far. Then you have to, of course, retract that back for it to not crash into your car or to not get into the next rotation when it's out already. Because that can be really dangerous. It would be like you hit a rock in the road. You can even crash your car if that happens. That also suggests that if you ever lose power, all of these spikes should immediately retract back. If that fails, you are also going to crash your car probably. Project suggests that these linear actuators are going to have rubbery tips so they can connect to the road surface better, but I'm not really sure about that. First of all, this is still a really small surface area. There's lots of imperfections in the road. In a perfect environment, the friction is not actually connected to the surface area. But real world is not perfect. Rubber and roads are definitely not perfect. And when they are spinning this much high revolutions per second, the more contact surface area you have, it is better for your car's handling and for your safety. So when accelerating, you still want more contact area. In wet or wintry conditions or in sand and dirt, this is going to be even a bigger problem. Also, that much high force and friction and heat in a small rubber tip, it is not going to be reliable. Like, we have to replace them like every month maybe. So how are we going to do that? Who is going to do that? Also, our actual tire in the wheel has to have little holes in it. So we need custom made tires too for this project. Everything gets even more complex and complex. I don't even think this David Hansen really thought this through. Like I said, this is a creative idea, but this has lots of problems with how world actually works. When you think about the movement, what these linear actuators do, they are coming out, connecting to the road and coming back in. All of this movement, if you don't push the car forward, if you think about you are not using any energy to push the car forward, it is all a complete loss of energy. You are wasting energy to that movement. You have to reach out to the road and still have that same exact point as your contact point. You have to keep pushing out, and then at the last point you have to retract back. All of that is loss of energy. And when you're accelerating, you are doing this with 200 of these linear actuators, 12 revolutions each per second. That is lots of movement of spikes everywhere. All of that is lost energy when you are accelerating. When you are pushing the car, yes, you are pushing it, but to push the car, you are doing all those nonsense movements. And we can't even have braking with these linear actuators. Maybe we can have, but it would be even more complex to have them decelerate the car. Like, that can go wrong really badly. Just trying to stop the car with these ahead, that wouldn't work, or that would just put on even more pressure and heat into our rubber tips. So we are going to have regular brakes anyway. And in electric vehicles, since this is going to have a battery, this is still an electric vehicle, the regenerative braking is really a marvel. It helps to gain that energy back when you are slowing down your car. Because you put in really so much energy to accelerate your car, now your car has lots of kinetic energy. And if you brake with regular brakes with friction, all of that energy is wasted into heat. So thanks to regenerative braking, we can have more miles from our cars. It helps so much. And if you want to put regenerative braking into this project, then where we are going to put it really? Is it going to be in the wheel? Is it going to be in the car still? So we are still going to have the wheel connected into an electric engine? That doesn't really make sense, is it? It is going to defeat the whole purpose of this project. If you have an electric engine anyway, you can use it both to accelerate the car and to slow down the car. And this actually gives us another idea. Maybe we should just put an electric engine into the wheel. So we don't need 200 of linear actuators. We can just have a single electric engine in the wheel that can still turn the wheel. Another thing is, this is really a very heavy wheel now. If your car tires are not slipping, you are always having a contact with the road. So if there's no slipping, it really depends on how much you can slow down your wheels for your car to slow down eventually. When braking, we are just trying to slow down our wheels. And if your wheel is this much heavy, it has all of these linear actuators and parts in it, it is going to be harder to slow down. It is going to have more rotational inertia, rotational momentum. That is going to put more load into your braking system. Also, it is going to negatively impact your braking performance overall. Another problem is, remember when we talked about these linear actuators having a vertical vector force that is going right up into the wheel itself. So you are going to be having all of these random immediate pushbacks for your wheel and for your suspension from contacting the road. That is a vertical force that you are artificially introducing to the system. So I'm not a physicist or an engineer, so I cannot really pinpoint where this really affects the car. Maybe you guys can think about that. Let me know in the comments down below if this really affects the car. What I can think about is, if you mess up contacting the surface here, those forces can send vibrations or oscillations to your wheel and to your car that can affect the comfort or your safety or overall reliability of the system. And one last thing is, having this heavier wheel turning at high speeds, it is going to affect multiple things. Your joints to the car has to be stronger, the overall casing of the wheel has to be stronger, even the overall tire has to be made for this force, and all of these heavy parts will be turning with these high forces. It really has to be high quality parts, and maybe overall all of this project has to be made by the best engineers in the world. There's lots of problems, and probably Actually, I even skipped some of them. So I would say we really don't have to reinvent the wheel. So what do you think about this? Do you think this would work? Do you have any additional points? What's your perspective on this project? Did I make any mistakes here? Let me know in the comments down below. If you liked the video, please subscribe and share this with your engineering friend. Probably has even more valid points to make about this. And who knows, maybe I am going to be proven wrong. Thank you for listening.